Hi, welcome to my video on extra practice on the quadrilateral unit. Extra practice. Classify each quadrilateral with the best choice and state the reason. Remember, you can always pause the video, work with these answers, and see if you understand what this unit is about. Number 1, A. We have two parallel sides. Your best choice here would be to call it a trapezoid. We have two parallel sides. And the reason a trapezoid has only one pair of opposite sides parallel. And what's the best choice here? I see four right angles, so we could, and I see no sides, I see opposite sides equal because the best choice is a rectangle. All the sides are not equal, so the best choice is a rectangle, not a square, because we don't have all the sides equal. Reason is four right angles with all the sides not equal. C, adjacent sides are equal here. Adjacent sides are equal here, so the best choice is a quoit. A quoit has two pairs of adjacent sides equal, and there's no parallel segments or lines. And right here we have four sides equal and four right angles. The best choice here is a square because all sides are equal and all angles are right angles or equal. And E, we have opposite sides parallel, so the best choice here is a parallelogram. We do not know about opposite sides are equal. We don't have any right angles, so it's not a rectangle or a square. And we don't have all the sides equal, so it's not a rhombus. So the best is the reason is definition of a parallelogram, which is opposite sides are parallel. And the best choice here is four sides equal is a rhombus because there's four sides equal. And we have no right angles, so it's not a square, just a rhombus. Number 2, we have a parallelogram, we have a rectangle, we have a rhombus, we have a square, we have an isosceles trapezoid, and we have a quoit. And select from the above in number 2, all 6 of these, which one or ones have the diagonals that. Diagonals are a segment drawn from one vertex to another, staying on the inside. So these are the diagonals. Two diagonals. See the diagonals, two of them. There's the two diagonals going from one vertex to another, not being a side. Two diagonals. Select the ones that the diagonals bisect each other. So diagonals bisect each other in a parallelogram, in a rectangle, in a rhombus, and in a square. So here the diagonals don't bisect each other. The long one, which is this one, bisects the short one. And then the isosceles trapezoid, they don't bisect each other. In other words, this part here is not equal to this part. And which ones are congruent? The diagonals are congruent. So the diagonals are only congruent when we have right angles. The diagonals are congruent when we have right angles if it's a rectangle. So we got to be careful on that one, right angles. The diagonals are congruent when we got a square, and there's one exception to that. The diagonals are congruent in an isosceles trapezoid. Not only when it's right angles. In a trapezoid, if it's isosceles, but it has to be an isosceles trapezoid. So in a rectangle, the diagonals are congruent. In a square, the diagonals are congruent. But the diagonals are not congruent or equal in a parallelogram or in a rhombus. You can see that this diagonal is longer than this one. And this one here is longer than this one, so they're not congruent. Which ones are the diagonals perpendicular? That would be true when all the sides are, the diagonals are perpendicular in a rhombus. In a square is true for all of them. And a kite, the diagonals are perpendicular. In a kite, the long one is perpendicular. In a kite, they're perpendicular to each other with a right angle there. And again, the long one bisects here, so they're perpendicular in the rhombus, in a square, and in a kite. Bisect two pairs of opposite angles, and that happens in a rhombus, happens in a square, and it happens in a kite. They bisect two pairs of opposite angles. So that happens in, let's see, don't happen in a kite. Nope, that's wrong. Sorry about that. Bisects one pair of opposite angles. One pair of opposite angles bisects one pair of opposite angles. Nope. That's two pairs. Nope. That's two pairs. That's bisects one pair of opposite angles. It would be an isosceles trapezoid. One pair base angles. Only bisects one diagonal, bisects only one bisects the other. That's in a kite. The long one bisects the short one, but the short one doesn't bisect the long one. Okay, let's continue. Practice again. Pause the video and let's move through all the properties again. Mark an X if the quadrilateral has the property. Properties of a quadrilateral are labeled down here. And opposite sides are parallel in a parallelogram, in a rectangle, in a rhombus, in a square. Opposite sides are parallel, no. In an isosceles trapezoid, no. Opposite sides are parallel, no. In a kite. Trapezoid has only one pair, and a kite has none pair. Opposite sides equal in a parallelogram, rectangle, rhombus, square. Nope. Nope. Opposite sides, no adjacent sides, not in a kite. Opposite angles equal. Parallelogram, rectangle, rhombus, square. Opposite angles are equal in, nope, not in a trapezoid, nope, and not in a kite. And consecutive angles are supplementary. Oh, sorry, the diagonals bisect each other in a parallelogram, in a rectangle, in a rhombus, in a square. The diagonal, no, no, and no. And consecutive angles are supplementary. That's in a parallelogram, a rectangle, a rhombus, and a square, and a trapezoid. Nope. Consecutive angles are supplementary. Not in either one of these. 4 right angles is only in 4 right angles in a rectangle and in a square. Diagonals are congruent. Rectangle, yes. Rhombus, no. Square, yes. And an isosceles trapezoid, yes. Not in a normal trapezoid. And the diagonals are not congruent in a kite. 4 sides congruent in a rhombus and in a square, not in the rest. Diagonals are perpendicular in a rhombus, not in a rectangle, not in a parallelogram. In a square, yes. Diagonals are perpendicular in a normal trapezoid, no. Isosceles trapezoid, no. In a kite, yes. The diagonals bisect the opposite angles. Parallelogram, no. Rectangle, no. Rhombus, yes. And a square Yes. Diagonals bisect the opposite angles? No. No. Opposite bisect all the diagonals? No. Only one diagonal bisects the opposite angles. One pair of sides parallel, that's true for a trapezoid, and is true for an isosceles trapezoid, but none for a kite. Legs are congruent, that's only in an isosceles trapezoid. Legs are in terms of the trapezoid. Base angles are congruent in an isosceles triangle. We got base angles. Only two pairs of adjacent sides are equal. None are parallel. That's in a kite. Mark it right here. Only one diagonal is perpendicular to the other. Only one diagonal is perpendicular to the other. One diagonal is perpendicular to the other. Both are in a kite. Isosceles trapezoid, trapezoid. Can't mark any. Only one diagonal perpendicular. The sum of the interior angles is 360. That's true for parallelogram, rectangle, rhombus, square, trapezoid, isosceles trapezoid, and a kite. Only one diagonal bisects the opposite angles. That's true in a kite. So just a review of the properties. Just a review. Hopefully you're seeing the properties as I do, but it takes a while to memorize them. So let's move on to place always, sometimes, never in the blank to be true. A rectangle is a rhombus. I'm going to put S for sometimes. A rectangle is only a rhombus if the rectangle got four sides equal. A rhombus is a parallelogram, and that's A for always. A rhombus is always a parallelogram. A kite is a parallelogram, and we'll write never. A kite has only adjacent sides equal, not opposite sides. A kite has no parallel sides, so it's not a parallelogram. A square is a rhombus, always. A square is always a rhombus, but a rhombus is not always, sometimes a square. A square is the regular, so it has all the properties of parallelogram, rhombus, or rectangle, etc. Parallelogram is sometimes a rectangle. Why sometimes? Because if you give a parallelogram a right angle, you have a rectangle. A trapezoid is a parallelogram, and we say never. Because a trapezoid is only one pair of sides. So if you say only one pair, it can't have two. Number 2. Remember, don't forget to pause the video if you want to work them out. If a quadrilateral is a rectangle, then the quadrilateral is also, so if it's a rectangle, it's also a parallelogram. A quadrilateral is a square, then the quadrilateral is a parallelogram. It's a rectangle. And it's a rhombus. A square is all the other rectangles. I meant the relationship between a parallelogram, rectangle, and rhombus is opposite sides are parallel. Opposite sides are equal in a square, and that's true. Square got right angles, so a square can be any one of these, but not necessarily. So is a parallelogram a square? Sometimes. Is a rectangle a square? Sometimes. Is a rhombus a square? Sometimes. Number 3, classify the parallelogram math, M-A-T-H, as a rectangle, a rhombus, or a square if TM equals AH. If the diagonals are equal in a rectangle, then you will have diagonals are equal, you'll have a rectangle. So we don't know anything about the adjacent sides, we don't know anything about the angles. So if a parallelogram has the diagonals equal, then we have a rectangle. TM is perpendicular to AH. If TM is perpendicular, we have a right angle. So if we have a right angle, right at the diagonals intersect at right angles, then that would be true. Parallelogram of perpendicular diagonals would be a rhombus. Because if they're perpendicular here, and here. These triangles are going to be congruent, so the adjacent sides are equal. These two triangles are going to be congruent, so these two sides are equal. That ends up to be all the sides equal, so we have a rhombus. MAT, MAT. If MAT, a parallelogram with a right angle, MAT is a right angle, that means we have a rectangle. We don't know anything about the sides, so it can't be a rhombus or a square. If MA equals AT, adjacent sides equal, then we have a rhombus, because if the adjacent sides are equal and the opposite sides are equal, then all the sides are equal. If MT equals AH, so the diagonals are equal and the diagonals are perpendicular, then we have a square. The diagonals are equal and perpendicular, then we have a square. Diagonals are equal, we have a rectangle. Diagonals are perpendicular, we got a rhombus. But when they're both, we got a square. MT bisects HMA. MT, this diagonal bisects HMA and bisects HTA. So the diagonal is bisecting the opposite angles. So if you bisect the opposite angles, you will have a rhombus. Because we don't know anything about the right angles. If we bisect, we have rhombus. We can't, okay, there's the right angles here. So we don't know the square. If HMA, if that's a right angle, and HM is equal to MA, so we have a right angle and adjacent sides equal, so that makes it a square. Because if this is a right angle, opposite angle is a right angle, and the adjacent angles are supplementary, so that's a right angle, that's a right angle, this happens, so there's 4 right angles, and if the adjacent sides are equal, opposite sides are equal, so all the sides are equal, so we have a square. Again, different thinking, trying to keep you thinking along. State the converse of each and state if true or false. If false, state the reason why. Here we go. A converse, you switch the statement. If a quadrilateral is a rectangle, then the diagonals are equal. If a quadrilateral has the diagonals equal, then it's a rectangle. It's apostrophe S, then it's a rectangle. And the answer is false. I'm going to draw a little diagram here now. So let's say we have this situation. There's the diagonal. So let's say that AB is the diagonal. So now I'm going to draw this figure. So I'm going to make this one. So here it is. So if I go A, C, B, E. So this is the diagonal. This is the diagonal. These are the diagonals. Then notice that this diagonal is equal to this one, but these two sides are not equal. So it's false. It's not true. Let's continue. Converse again. If a quadrilateral is a parallelogram, then the diagonals bisect each other. So if the diagonals of quadrilateral bisect, there's no S there, bisect each other, then the quadrilateral is a parallelogram, and that's true. Oh, I'll go back to here, sorry. Go back to here just for a second. I forgot to say that it's false. Forgot to put false on this. This is false. And right now, we have that as true. Once it's true, is true. If a quadrilateral is a rhombus, then the diagonals are perpendicular. If a quadrilateral has the diagonals perpendicular, then quadrilateral is a rhombus. And that's false, because if you take a kite that's like this is a kite. If you have a kite that has two pairs of adjacent sides equal, the long diagonal is going to be perpendicular to the small one. So if the diagonals are equal, it's not a rhombus. This is a kite, so it's false. If a quadrilateral is a kite, then the longer diagonal bisects the opposite angles. If the longer diagonal bisects the opposite angles of a quadrilateral, then the quadrilateral is a kite. And if the longer diagonal bisects the opposite, so what we're saying, this is true. What we have is a kite. The longer bisects the opposite angles. So we got a longer diagonal, which is this one. We got a shorter diagonal, which is this one. So if the longer diagonal bisects the opposite angles, so the longer diagonal makes this angle equal to this one, and makes this angle equal to this one. Because it bisects, that makes these two triangles congruent. So triangle A, B, C, we mark a D, triangle A, B, D is congruent to triangle CBD, and that's by angle common side, so it's an SAS congruency. So this is the common side, so it's an, whoops, my mistake, angle, side, angle. I don't know where we're getting the two sides, angle, side, angle congruency. Sorry for that. Angle, side, angle, angle, side, angle. So it's true. And therefore, because the triangles are congruent, then this ends up AB equals CB, and AC equals AD equals CD. And therefore, we have a kite, because opposites adjacent, two pairs of adjacent sides are equal. And this is the last page. Let's continue. The more work we do, the more the better you get. Fill in the blanks with the correct answers. To prove a quadrilateral is a parallelogram. If I want to prove that a quadrilateral is a parallelogram, I prove two pairs of opposite sides parallel. I can prove that two pairs of opposite sides are equal. I can prove one pair of opposite sides parallel and one pair of opposite sides parallel and one pair of opposite sides parallel and one pair of opposite angles equal. This little mistake here, this should be sides. One pair of opposite sides parallel, one pair of opposite sides equal. There's a mistake here. If you have one pair of opposite sides equal and parallel, you got a parallelogram. If the diagonals bisect each other, then you have a parallelogram. If you have two pairs of opposite angles equal, you have a parallelogram. So that angles right there should be, that would be one pair of opposite sides parallel and one pair of opposite sides equal. If we want to prove that a quadrilateral is a rectangle, we need to have 4 right angles, or we need a parallelogram with a, so if we take a parallelogram, if you have a parallelogram and you make it one right angle in it, then you'll have a rectangle. If you have 4 right angles, you automatically have a rectangle. Also, there's probably a third one here. If you have 3 right angles, you have a rectangle. So you could have 4 right angles, you could have 3 right angles. Why? Because if you got 3 right angles, that's 270. Then the other angle must be 90. So if you gave 3 right angles, you must have a 4th one. Number 3, a rhombus. Remember, don't forget, you can pause your video and write in these answers to see if you're correct. A rhombus is 4. By definition, a rhombus has 4 sides equal. Or a rhombus is a parallelogram with a pair of adjacent. A rhombus is a parallelogram, a pair of adjacent sides equal. So if you take a parallelogram, which is this, parallelogram got opposite sides equal like this, but if you make the adjacent sides equal, so if that one got 2 strokes, if these 2 are going to be equal, so this got 2 strokes. If these are adjacent sides equal, that got to be 2 strokes. If this one is equal to this one because the pair of adjacent sides are equal, then it happens that the opposite sides are equal and the adjacent sides are equal, so we have a rhombus. Number 4, prove a square has 4 right angles and 4 sides equal. That's by definition, 4 right angles and 4 sides equal. Or a square is blank with a pair of sides equal. It's now, what do we say here? A pair of blank sides equal. So if we take a pair, we take a rectangle, which has 4 right angles, and we have a pair of adjacent sides. So if we take a rectangle which got 4 right angles, and you make the adjacent sides equal, well, that's the same as here. If the adjacent sides equal and the opposite sides are equal, then they're all equal. So we got a square. If we take a blank with some angle, so if we take a rhombus, which has all sides equal, and give it a rhombus with a right angle, is a square, because a rhombus has opposite angles equal, and if you have one right angle, then the opposite angle is a right angle, and the adjacent angles, so if you think about it, if we take a rhombus and make it a right angle, so rhombus has all sides equal, and if you give it one right angle right there, that means the opposite angle is a right angle. These 2 angles here are supplementary, so that's a right angle. These 2 angles are supplementary, so that's a right angle, so we have a square. Parallelogram with the diagonals, let's see, the diagonals bisect each other. The diagonals are equal, and they bisect. Well, the parallelogram bisect is automatically if a parallelogram is with the diagonals equal and perpendicular. The diagonals of a parallelogram are equal and perpendicular, then we get a square. A square is a blank with diagonals equal. A square is a rhombus. A rhombus has 4 equal sides with the diagonals equal. We can't, if we say a rectangle automatically has the diagonals equal. So a rhombus with equal diagonals is a square. A blank with the diagonals perpendicular. A rhombus got the diagonals perpendicular, so this is a rectangle. A rectangle has the diagonals equal. So if you got a rectangle with the diagonals perpendicular, again you got a square. Again, these properties Got to be careful. Even sometimes I think wrong, so got to be careful. A trapezoid. To prove a trapezoid, we prove only one pair of opposite sides parallel. A kite. Prove two pairs of sides, two pairs of adjacent. To get two pairs of adjacent sides equal with no parallel lines. So we reviewed all the properties, just as a general review. Hopefully you have a better understanding. And if you do, click on the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.